Screencastify because Screencastify said, yeah. So, okay, here we go. Boom, boom. Hyperbolas. We're going to look at the geometry of hyperbolas and translations. And yeah, we're going to try to stick to the basics of hyperbolas. A hyperbola is a set of all planes whose distance from a fixed point in the plane have a constant difference. The fixed points are the foci. The line through the foci is called the focal axis, where the center of the two foci is called the center. And then you have parabolas. They're double parabolas, and yeah, it's wrestling week. Jesus. Jorgie, make this quick. That's fine. So we'll... Okay. Just email me their actual records and I'll fix them. Yeah. Okay. Well, we'll talk later. All right. Bye. All right. So the vertices of the two parabolas are the vertices of the parabolas of the hyperbola. And so you'll see what's going on. Okay. Great picture. Parabola, parabola. Two parabolas. That's what a hyperbola is. Two parabolas that have a center halfway in between the vertices, halfway in between the focus. The focus, the parabola wraps around the focus, and that's what it looks like. Okay? So this one's a left, right, and then you have an up, down, too. Okay? Any point is a certain distance away. So it's a different equation than it was for ellipses. Your equations are these. There you go. Where c squared equals a squared plus b squared. So it's the Pythagorean theorem. In ellipses, a squared equals b squared plus c squared. But in hyperbolas, c squared equals a squared plus b squared. The big difference between ellipses and hyperbolas, minus sign. And be careful where you put the x's and y's. That is super important. Go. Okay, sounds like most of you have this written down. So, it's very similar to, what we've been doing. So it's yet one more slightly new concept, but it's similar. All right. So you have asymptotes that go through the center that have your hyperbola go near it. Okay. So if x is positive, it's a right-left hyperbola. If y is positive, it's an up-down hyperbola. That's very, very, very important to understand. Okay, you might want to write that on your own card. By your x positive one, it's right-left. By your y positive one, it's up-down. Okay, notice how it's b over a and negative b over a for your right-left asymptotes, and it's a over b and negative a over b for your up-down asymptotes. Okay, so it all depends where they're at. Okay, so let's look at this one. To start an equation, you always have to have 1 on the side, just like ellipses. So we're going to divide by 36, divide by 36, divide by 36. So you get x squared over 4 minus y squared over 9 equals 1. So this is going to be up, down, or left, right? Left, right. So C is going to be here and here. A is going to be there and there. Okay? So we're supposed to find the vertices and foci. So this is centered at 0, 0. If you had x minus something and y minus something, it wouldn't be centered at 0, 0. But since it's centered at 0, 0, A is under the x. Okay? A is under the positive 1. Okay? A is under the positive 1. So A is 4, so your foci are at 2, 0 and negative 2, 0. Because you take the square root of this, and that's how far you go away from the center. Can you handle that? It's not too hard. And then c squared equals a squared plus b squared. So c squared equals 4 plus 9. C squared equals 13, so c equals the square root of 13. So your foci are at square root of 13, 0, and negative square root of 13, 0. Your foci and your A is along your major axis. So if it's a left-right, you'll have answers in the x values. If it's an up-down, it'll be 0, whatever. So answers in your y values. Okay? If it's centered at 0, 0. Are we all right with this? Okay? Which, look, Mr. Bierschbeck got it right. Wow, isn't that amazing? Okay, find the equation of a hyperbola with these foci and whose conjugate axis. The conjugate axis is the minor axis, okay? Not the major axis. So, C equals 4. The conjugate axis has a length of 2, so B equals half of this, because your length is half of it. So it's 1. So c squared equals a squared plus b squared. So 16 equals a squared plus 1. So a squared equals 15. So a equals the square root of 15. Okay? So since the focuser is on your y's, y is positive. That's over a squared, so over 15, minus x squared over the conjugate axis, 1, equals 1. A squared, b squared, and then your foci isn't part of the equation. It's how you figure out the equation. Okay? So Mr. Bierschbach was right. Again. So if it has a center of HK, everything's the same except for your adding and subtracting. I'm not going to have you write this down because you're just adding and subtracting to wherever your center is. Okay? You've done this with ellipses. You've done this before, so we're good. I want to go straight to the assignment now. All right. So the vertices of the hyperbola and the foci of the hyperbola. Okay? Where's the center of this? Center is at 0, 0. Okay? So your vertices are how far away from the center? 5. They're 5 away, and x is positive. So they're at 5, 0 and negative 5, 0. The foci, c squared equals a squared plus b squared. Because a is the square root of 25, b is the square root of 6, so a squared plus b squared. So c squared equals 31. C equals plus or minus the square root of 31. So it's square root of 31, 0, and negative square root of 31, 0. Okay? Foci are C. Major the vertices are A. Vertices and foci of this one. What do we do first? Divide by 36. So x squared over 4 minus y squared over 9 equals 1. Unlike ellipses, you can have a bigger number on your minor axis. Okay, you can have a bigger number on your minor axis. Center is 0, 0. Your major axis is the x-axis. The square root of 4 is 2. So your vertices are at 2, 0 and negative 2, 0. Your foci, c squared equals a squared plus b squared. C squared equals 13. C equals the square root of 13. So it's square root of 13, 0, and negative square root of 13, 0. You're matching up hyperbolas here. The center of this one is 0, 0, and it's an up-down one. The center of this one is 0, 0, and it's a left-right one. The center of this one is 2, negative 1, 2, negative 1, and it's a right-left one. The center of this one is negative 3, 2, and it's up, down 1. Okay? So you can just figure out where the center is and then figure out left, right, up, down for the matching. Which is the correct graph of this one? Okay? Center is at 0, 0. A is how far? What are the two vertices? A is what here? 4. So the vertices are at 4, 0, and negative 4, 0. It's a right-left one. Has to be that one. That's all it can be. This one, A is what? A is 5. So it's an up-down one. Vertices are at 0, 5, and 0, negative 5. This one. If there was a plus sign here, it would be this one. But there's not a plus sign. It's a minus sign. It's a hyperbola, not an ellipse. Where's the center of this one? Negative 1, 1. Negative 1, negative 1. Excuse me. Negative 1, negative 1. And you go 2 to the left and right, and it's a right-left one. So negative 1, negative 1. 2 to the right and left. Must be that one. Okay. Graphing calculator says make a hyperbola. It's a right-left one. That's 10 each way. And then, so it's this one. which two functions produce this? You got to get y alone. So to get y alone, you go negative y squared over 9 equals 1 minus x squared over 100. Multiply by negative 9, y squared equals negative 9 plus 9x squared over 100. And then get a common denominator, so this would be 900 over 100. Take the square root of each side. So y equals the square root of 900, negative 900, plus 9x squared over the square root of 100 is 10. So 9x squared minus 900 all over 10, and then it's the square root of that. Okay, that's the same. Okay, the foci are here. The transverse axis is here. The transverse axis is your major axis. Transverse axis is your major axis. So if this is 12, what's half of 12? 6. So A equals 6. C equals 12 from your foci. So 12 squared equals 6 squared plus B squared. 144 equals 36 plus B squared. 108 equals B squared. So what's the equation? Well, it's a 0, 12, so that's an up-down one. So y is positive. So y over your major axis squared, 6 squared is 36, minus x squared over your minus axis squared, well, b squared is 108, equals 1. Y squared over 36 minus x squared over 108 equals 1. All right. So here your center is at 0, 0, B is at 7, and it's a vertical focal axis. So it's y squared over something equals x or minus x squared over 49 equals 1. We just have to find this. Well, your eccentricity is C over A, right? So C equals 25, A equals 24. So what's 24 squared? 600 and, ooh, it might be 576, right? 576? So that should be your equation. Because your eccentricity gives you C and A, and here is B. Ta-da. So those are the 10 problems you'll have. I'm going to put out the practice test too, just to let you guys get started. We'll review on Friday. And then if we need to figure out any more reviewing on Monday, we'll review on Monday some more. And then we'll take it Wednesday. And we'll call it good. Does anybody vote that we need to have a quiz over this stuff? Okay, so we'll just see this stuff on the final test. So there'll only be a few problems on the final over this. You can go fill your water.